Hey y'all. I wanted to talk to you guys about this slide. This is slide 5 from our 2.1 Polynomials Modeling Sunspots Desmos activity. Now, a lot of people have been able to uh, work on this slide, but there's been some confusion about it, and so I figured I would just make a quick little video discussing it. So first of all, in this slide, we are asked to graph the data for the number of sunspots as a function of the number of years since 1990. Decide which two columns from the previous slide would be best to plot this function and input this data into the table. So looking at the previous slide, we have the years 1991, 1992, and so on. We have the years since 1990, which we should have filled in as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have the number of sunspots in those years, right? So what I'm going to do is I think that the two columns that we should be considering is the years since 1990 and the number of sunspots. The actual year doesn't matter as much because we care about the number of years since 1990, right? So X is going to be my number of years since 1990, and that went, as we saw on the last slide, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I need to copy the data from the previous slide onto here. So I want this data here in that slide. Now that's going to be kind of annoying. I'm going to cut this part of the video, but I'm going to go actually input all that one at a time. Great, so I've put in the data, and you can see if I zoom out, I find all the data right here. Now, some people have pointed out to me that that looks really not nice. So that's why I've asked you to use the wrench icon in the top right of the screen to change the axes, and also we're going to label them. So let's look at how are we going to do that. So I'm going to click this, and you can see here's my x-axis and my y-axis. What does my x-axis represent? Well, as we talked earlier, it's the number of years since 1990. So I'm going to label that number years since 1990. And the y-axis is the number of sunspots. And then I should change my window. Well, my x-axis only really goes from 1 to 10. So what I'm going to do is I'm going to make it go from, I like to go in the negative a little bit. So I'm going to make it go from -1 to maybe 12, just so I can kind of see, right? And then my y-axis, well, the y values at the lowest go to 9, at the highest are 146. So I'm going to make my y-axis go from, let's say, -10 to 150. Just because that's lower than my lowest and that's higher than my highest. And you can see here, now I can actually see the data in a much nicer fashion, right? Now what we're doing is this. We are choosing which regression model is appropriate for this data. A regression model is just a model that approximates data, because when I have a pattern, right, in real life, it doesn't always match a perfect, like, y equals mx plus b or some perfect function, right? But we can make things that approximate them pretty well. Luckily for us on Desmos, we have these tools which actually can do that approximation for us. So you can see here, if I click it, if I click this one for the linear regression model, this line here is a linear regression, which is attempting to model the data we provided. Doesn't look like it's modeling it very well, huh? So I know that linear regression is probably not the model that I need to use here for this data. What about quadratic regression? That looks a lot better. See how this equation, right? This y equals ax squared plus bx plus c, where a is these numbers, right? A is 6.01, b is -67.5, c is 204.9. This one looks a lot closer to the data. So this is a pretty good approximation. Let's just see the exponential just to test before we make our choice up. You can see that when I do an exponential regression, it doesn't match it very well either. So I think that I'm going to use the quadratic regression model for this particular problem.